Okay, so in this video, I'm going to give you a basic overview of sequence and series, kind of as an introduction to our unit. What is a sequence? What is a series? And a few just basic problems to get us started with both. Just to remind you, a sequence is an ordered list of numbers, and a series is an indicated sum of the terms in a sequence. So if I have a sequence, it's just an ordered list of numbers. So for example, I could say 2, 4, 6, 8. And it can either be finite and end, or it can be infinite and continue forever. And a series would be the sum of that sequence, so 2 plus 4 plus 6 plus 8. This would be a finite sum, or the fourth partial sum, or I could have an infinite sum that keeps going. So what we're going to do is take a look at just a couple sequences where I'm giving you the definition of the sequence, and we're going to find the first 4 terms. And then we're going to find a couple sums, look at some series. We're going to find one from an equation and one set up as a summation. So let's take a look. So let's say that I have a sequence. If I have a sequence, I can either define it like this recursively or like this explicitly. So we're going to look at an example of each. So let's say I have a recursive definition, which means that I'm telling you what to do to the previous term to find the terms in our sequence, and we have to go one by one. So I'm going to have to give you a starting point. So we have that the first term, when n equals 1, our first term is 3. So we're going to have 1, 2, 3, 4. We want the first 4 terms of the sequence. So let's say I have a1 equal to 3, then that means to find a2, we would be doing 2 times the previous term, and minus 1 would be a1. So we're going to do 2 times 3, which would give us 6. So far we have 3, 6, we just need 2 more. If I have the third term, a3, then I'm going to do 2 times and minus 1 would be a2, so we're going to do 2 times the previous term is 6, and that would give us 12. And lastly, if I have a4, we would be doing 2 times and minus 1 would be a3, so we'd be doing 2 times 12 is 24. So you have 3, 6, 12, 24 as the first 4 terms of our sequence. Let's look at number 2. Number 2 is defined explicitly, so I don't actually need the first term and I don't need the previous term to find any individual term, but we are going to go ahead and find in order the first, the second, the third, and the fourth term. But what I'm going to do is I'm going to be just plugging in n to find an. So for a1, I'm going to say 2 times 1 plus 1. For a2, I'm going to say 2 times 2 plus 1. For a3, 2 times 3 plus 1. And for a4, 2 times 4 plus 1. And what we end up with is 2 plus 1 would be 3, 4 plus 1 would be 5, 6 plus 1 would be 7, and 8 plus 1 would be 9. 3, 5, 7, and 9 are the first 4 terms of our sequence. Okay? Let's take a look at a couple sums or series. I want to find first the third partial sum of this sequence right here given to us explicitly. So what I'm going to do is just find the first 3 terms of my sequence, and then I'm going to go ahead and add them because the sum just means to add them up. So for the first one, I would have 2 times negative 1 to the first power plus 1. For the second one, 2 times negative 1 squared plus 2. And for the third one, 2 times negative 1 cubed plus 3. This would give me negative 2 plus 1 is negative 1. The next one would give me positive 1 times 2 is positive 2, plus 2 is 4. And the third one, negative 1 cubed is negative 1 times 2 is negative 2, plus 3 would be a positive 1. So I end up with negative 1, 4, and 1 as my first 3 terms of my sequence. And the third partial sum would be negative 1 plus 4 plus 1. Negative 1 plus 4 would be 3, plus 1 would give us a total of 4. That would be my third partial sum. Last example. We can also write sums in what we call summation notation with this sigma sign right here. And the number at the bottom tells us what term we're starting with. So we are starting with n equal to 1. And the number on the top tells us what we're ending with. So we're going to go all the way to the fourth term. And this is just our explicit equation for our sequence right here. So I'm going to find, similar to the last one, now that I have it set up, the first four terms, and then I'm going to add them together. So we'd say 3 times 1 minus 2, 3 times 2 minus 2, 3 times 3 minus 2, and for the fourth one, 3 times 4 minus 2. And that would give us 6 minus 2, oh sorry, 3 times 1 is 3, minus 2 is 1, 3 times 2 is 6, minus 2 is 4, 3 times 3 is 9, minus 2 is 7, and lastly 3 times 4 is 12, minus 2 gives us 10. So I have 1, 4, 7, and 10, and if I find the sum of those, 1 plus 4 plus 7 plus 10, gives me a grand total of 5 plus 17 is 22.